Alright guys, so how's everyone doing? Alright, so first of all, let me welcome you guys to the Unacademy JEE English. This is a brand new channel by Unacademy, and here every concept of physics will be taught to you completely in English. Alright, so this is a series that I host for class 11 students, and the topic that we are discussing right now is work, power, and energy, and this is lecture 2 of work, power, and energy. So before we get started with today's lecture, let me introduce myself quickly for those of you who still may not know me. So my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi. And for almost 8 years now, I've been teaching physics for IIT JEE, and all this teaching had been offline. So this is my first online venture. This is the first time I'm teaching online. Before this, I have done all my teaching offline only, but wherein I was associated with some of the topmost institutes in the JEE preparation field. All right. Next, I myself was JEE rank for All India rank 447 and All India rank 192 in the two stages of the IIT JEE exam that I took. I also qualified the NTSC Stage 2, and I was in the top 1% in the NSCP, which you guys should know is the National Standard Examination of Physics, commonly known as the first stage of the Physics Olympiad. Now, I've already coached many students to top ranks in the offline setup, and I hope to continue doing that here online with you guys. So how do you ensure that your studies are not catching a break and you are well prepared for hitting some top ranks in the JEE exam? So you will need to take your Unacademy subscription. This subscription can really help you boost your rank in the JEE exam. How? It will provide you live classes. It will give you a chance to interact with your educators. So even in this lockdown period when you can't go for your offline classes, you will have your regular classes online running just like your offline classes, and your learning will not stop. Alright. Then in these classes you have live polls and leaderboards, alright, which keep these classes highly interactive. You also have test series and analysis, so you are part of a test series which a lot of students all across India will be taking. So it will be a good way to assess your performance and identify the areas of improvement. Alright, so your teachers will help you with the analysis of your performance in every test, pinpoint your areas of improvement, and help you get over your difficulties. And of course, on top of all these benefits, you have live doubt clearing sessions, which is again a huge advantage with your plus courses. So in all your plus courses, every fourth session is supposed to be a live doubt clearing session. So after every 3 sessions of teaching, you will have a live doubt clearing session, which will ensure that your doubts do not get piled up and your concepts keep getting cleared as you go along. Hi Gopi Krishna, how are you? And on top of all these benefits, there is one particular benefit that I feel that the students will have the most, which is avoiding any distractions. So when you're studying online, when you're studying on YouTube, so you will realize that when you're watching a video, there are so many distractions, there are so many suggested videos on the side, and more often than not, one strays off the study videos and starts watching a lot of other videos and ends up wasting a lot of time. So when you are studying on your Unacademy app, that app will have only all the videos related to studies and lectures. So there you can just attend your classes, and trust me, it will be easier to log out of that once you are done with your studies. Alright, there are no distractions there. So again, I think these will provide a huge benefit and will propel you to some top ranks in the JEE. Now, on top of all these benefits, you will also get access to India's best educators with your Unacademy subscription. So Unacademy, what they have done is that they have caught hold of some of the topmost teachers in the JEE prep field, all from all across India, and they have brought them together on this single platform. So getting this subscription gives you an opportunity to study from some of the topmost faculties with successful track records in the JEE preparation field. Alright. So how do you get this subscription? Very easy. First, you'll need to install the Unacademy app. Once you have done that, you go to the plus section, you select your goal as IIT JEE, and you click on the get subscription button. Alright. When you are asked to pay the fees, you will realize that the fees has been kept highly competitive. This fees is very less for the kind of quality content and quality preparation support that you will be getting with your Unacademy subscription. When you go for any offline institute, they will charge you 8 to 10 times this fees. Alright. So you are getting quality education, quality help for your JEE preparation at a very reasonable price. This will become even more affordable if you use this code RDLive. So this is my code. When you plan to get your subscriptions, you can use this code. This will give you a 10% off on all these fees. Alright. So after that, when you click on proceed to pay, you will also be given a lot of options to break these payments into small amounts of no cost EMIs. Alright, so you will not feel the burden of this payment as well. All right, so make sure you are getting these subscriptions. You are getting the quality and the support that you will be getting for your JEE prep is definitely worth many times over the price that you have to pay. All right, so for those of you who are following us on the JEE English channel, you can connect with us on the Telegram app using the link shown above, so that you are getting all the notifications of all the sessions and lectures happening on the JEE English channel. Hi, Clevis. Okay, you just woke up. Okay. Sir, give us today deep sums. Okay, so what is deep sums? Okay, I, I see. Right now we are only on lecture 2, so I am just introducing the concepts right now. So I want you to conceptually understand the concepts first. Once you build a good understanding of these concepts, then we will move on to some tough problem solving. Don't worry. So initially, I will keep the problem solving a little easier just to get you familiar with the concepts and the ideas. All right. So don't worry. We will go up to some really tough level. All right. We will take our level up to advanced definitely, but we will do that slowly and steadily. All right. So as I said, why don't we get started with today's lecture? So this is lecture 2. In lecture 1, I introduced the concept of work. I told you how and what is the significance of that term F dot S. So we talked about how to define the work for a constant force and what the work would be for any of the forces and what would be the total work. All right, so I hope you watched that video carefully, because trust me, a lot of students have a lot of confusion regarding how to calculate work. So first you need to understand that well. All right. Next, we were talking about work done by a variable force, and I told you for calculating this, you divide trajectory, the trajectory of the particle in very small parts. All right, how are you? Okay, sleeping hardly for 1 hour. Why? You need to get some proper sleep. You don't want to overstress yourself. Trust me. All right. So Shashwat, get some sleep, get some sound sleep. You want to be in the best mindset for your exam. All right. So trust me, I've been there. I know how stressful it can be, and trust me, you want to be as relaxed as possible before the exam day. All right. See all the hard work you've already done in the past years. So trust me, keeping keeping yourself sleepless right now is not really going to help you much. It'll just exhaust you. Hello, Pavan. Good to see you. All right, so as I said, we discussed that for every small part of displacement, I can consider that this displacement is so small that for this, I can consider the force to be constant. And for constant force, I knew the work would be F dot that small displacement ds. Now that would imply this, and all I need to calculate the net work would be just to add all these works. All right, so I integrate this function of F dot ds, and that would give me the total work done by a variable force. And if the displacement and the force are unidirectional, they are in the same direction, then the work would simply be the area under the Fs graph. As you can see here, you should know that this integration just represents the area of Fs graph with this S axis. All right, so do not make the mistake of taking this area. It is always this area. All right. Good evening to you as well, Rishabh. So we also discussed that another way of calculating the work via a variable force would be if you write it in your component form. If you write the force in component form, if you have a 3D kind of force, then you can also break your displacement into 3 components of dx, dy, and dz, and then you can find the dot, and your work would become the integral of fx dx plus integral of fy dy plus integral of fz dz. All right. So this was just a quick recap of what we covered in the last class. So why don't you get started with a practice problem? Let's get you warmed up before we start today's discussion. So here is a question. You've been told that the fx graph is shown as follows. You have to find the work done by this force on an object in moving it from x equals 2 to x equals 6. Okay. So why don't you get started with this problem? Let's jog your memories and let's give you some practice. All right, guys. So get on with this problem. So Gopi Krishna says, sir, I have a doubt that in that graph, displacement and force, how will we find the angle between them at any instant? So that's what, you don't have to find the angle in the graph. Alright, in the graph, you don't have to find the angle, Gopi. Because the area under graph, as I said, this graph will be presented to you only if the force and displacement are in the same dimension. Alright, so only for 1D cases you will be given these graphs. So in 1D cases, the angle would either be 0 or 180. Alright, so that is the solution to your problem, Gopi Krishna. Alright, you can only draw the force versus displacement graph for a 1D thing. Alright, that is why you don't have to bother about the angle. If the work is above, if the positive and the negative signs will take care of the angle. Alright, so if the force is downward and the displacement is on the positive side, you will have negative work automatically. Alright, so that would imply that the angle is 180. Okay, so alright, so Pawan and Rishabh say that the answer for this is 360 joules. Let's see. So at x equals 2, you will realize, since this is a straight line, so if that is 60, then this would be 30, right? And at x equals 6, this is 2 beyond this. So let's try and find the area. So this is 2. So what you can do is, you can see that these two triangles are similar triangles. Okay, which ones? This one, and another being this one. So these obviously are similar triangles, so you can use that fact to calculate the height of this. Alright, so from here what you will get is that this would be 6 and this entire thing would be 8. Alright, so you can say that if this is y, if this is some y, from similarity you can say 60 y over 60 would be equal to 6 over 8. Alright. Yeah, so that is what you can do and find your similarity. Alright, hi AP, good to see you here. So now all you need to do is, this will go by 4 and 15, so then this is 3. So y, you will realize, is 45. So the height of this is 45. Alright, this would be 45. Now all you need to do is add the areas of the two trapeziums that you have here. The area of this one and the area of this one. Alright. That should be very, very easy. The area of any trapezium is half sum of the parallel sides into distance between them. So the area now, area between x equals 2 and x equals 6 would be half. The first area would be half sum of these sides, this being 30, this being 60, into distance between them, distance would be 2. Alright, so that would be half into 60 plus 30 into 2 plus half of 60 plus 45, that is the sum of the parallel sides, into distance between them, which will again be 2 only. Alright, so what you are getting is, you are getting 90 here, 90 plus 105, so that will give you 135 joules. Alright, that is the answer, guys. Not 360, not 195. What are you doing? What are you people doing? Yes, it will be 135. 90 plus 105. Okay, so sorry, 195. Yes. 195 is the correct answer. My bad. Yes, that is the correct answer. Absolutely, 195. It will be 90 plus 105. Alright. So you guys should be very, very careful about your calculations. I see you making a lot of calculation mistakes, which means you require more practice. So once these lectures are done, you make sure you are getting some more practice about calculating your work. Alright. So let's start another question. Okay, so here I have included this so that you get the idea of calculating work in different reference frames. Alright, in this question you've been told a person of mass 70 kg is going up in a lift with a constant velocity. Alright, you have to find the work done by the normal reaction on the person during the time when the lift went up from 12 meters to 20 meters A from the lift frame and from the ground frame. Alright, so what would be the work done by the normal reaction in both these reference frames? Alright, so let's see. Calculate this fast, this should be super easy. This should be super easy. Okay, hurry up. Acceleration is 0, yes. Lift frame 0, obviously. So lift frame work would be 0 because in the reference frame of the lift, the normal reaction will not do any work. Alright, so yes, that is correct. So somebody who is in the reference frame of the lift will not see any displacement even if the entire lift moves up. Alright, so this guy will not see any displacement of this object. So the lift reference frame work would be 0. And yes, the work from the ground frame would be very easy. It would be 5600. Yes, correct guys. So obviously you know, since the acceleration is 0, if the acceleration is 0, then your mg and n would have to be equal. Alright, so I can write, since acceleration is 0, I can say n would be equal to mg, which would be 700 Newton. And you see the force is upward and the block is getting displaced upward also. From the reference frame of an observer on the ground, he will see that the lift moves from here to here. Alright, so the displacement is also upward. So the angle between the force and the displacement, of course, becomes 0. And the displacement is 8 meters. So the work by normal reaction from ground frame would be 700 into 8, which would be 5600 joules. Alright. So please remember, by the way, if you have been generally asked to calculate the work without specifying the reference frame, by default you will calculate the work from ground reference frame only. Alright, remember this. Alright, now let's talk about some of the most common misconceptions about work and about some of the forces. So one very common misconception among people's mind is that normal reaction never does any work. Now you know that it can do work. Alright, it does do work. Alright, so a lot of people would say that, okay, normal reaction, you realize it is usually always perpendicular to displacement. Alright, even on an incline or even on a horizontal ground, but that's not always going to be true. Suppose if I push one block which is in contact with another block, now obviously on this the normal reaction between these two would do work, alright, when they get displaced. So normal reactions can do work. Next, people think that static friction can never do any work. So that is also a common misconception. So I will tell you why, and I can show you an example. So imagine if this phone is kept on my hand, and if I displace it from here to here. So what caused the motion of the phone? I did not apply any force, but since the phone moved, so there has to be a force that caused the motion. The force is static friction. Why static? Because there was no slipping happening between my hand and the phone, right? So the only force acting on this phone can be friction, first of all, and it has to be static. Why? Because there is no slipping between my hand and the phone. So it is static friction that acted. What will be the direction of static friction? It will be in the direction of motion only. Alright. It will be in the direction of motion only. That is why it is moving in this direction. So you have displacement in this direction, and you have the force acting in this direction. So static friction is actually doing work on this. Alright. So static friction can do work. And it can do positive work also and negative work also. Imagine when I am moving this. So initially, the static friction is doing positive work. But when I am slowing down my moving hand, if I am slowing down my moving hand, then what is the force that is slowing down this guy? Again has to be static friction. It was moving in this direction. If it was slowing, then the static friction was acting in the opposite direction. So static friction acting here and the displacement happening here. So here static friction is doing negative work. So not only can your static friction do work, it can do both positive and negative works. Alright. So Gopi Krishna says, sir, I have a doubt that if the body is not in equilibrium condition while the lift is moving with an acceleration or uniform velocity, then normal reaction is not equal to the apparent weight or actual weight. So apparent weight is the normal reaction. All your weighing machines, Gopi, they measure the normal reaction only. Alright, so when you are standing on the weighing machine, see what will weighing machine measure? So weighing machine typically has a spring in it, right? So when you're standing on a weighing machine, it typically has a spring in it. So when you are standing on it, what is the force that you are applying? What is the force that you are applying on the machine? That would be the normal reaction. And machine will apply a normal reaction on you. Alright. So this normal reaction will cause the spring to compress, and in equilibrium, if the spring gets compressed by some x, so kx would be equal to normal reaction. That is how your weighing machines measure your weights. Okay. That is how your weighing machines measure your weights. They are essentially measuring your normal reaction. Alright. They never measure mg. They're not measuring weight. They are measuring apparent weight, which is equal to the normal reaction. All right. So if your lift was accelerating, then obviously your weighing machine would give you a different answer than your mg. All right. I hope that makes it clear. Let me know if that is clear. Okay, I'm waiting. I'm talking in both cases. So in both cases, if you realize you make an FBD of yourself. So you have two forces acting, one mg, another n. So you will realize that the net force would be mg minus n, and that should be equal to na. N minus mg should be equal to ma. So if the acceleration of the lift is zero, if a is zero, then you will get n equals mg. So in that case, your lift will in fact show you your true weight. But if a is non-zero, then your weighing machine will show you a different reading. Okay. Hi Prabhat, I'm good. How are you? All right. So I hope that should make it clear. All right. Similarly, next, again, there is another very big misconception, which is that people think that kinetic friction always does negative work, which is incorrect. It is not necessary. In usual cases, when you see kinetic friction, sir, do N and mg act on same or other objects like earth and block? Okay, so N and mg can act on the same body, right? See, mg is acting on all bodies in any case. If the body is in contact with the solid, N also acts on it. Alright, see, mg acts for a different reason, N acts for a different reason. And Prabhat, you really need to watch my first video on Newton's laws to understand this better. Trust me, there I have explained normal reaction in great detail. You just need to watch that video and you will never have any doubt relating mg and N. Alright, I understand a lot of people remain confused about the relationship between normal reaction and mg. So you need to watch my first video. Alright, first video of Newton's laws, NLM 1, lecture 1. You watch that and you won't have any more doubts. Okay, so let's get rid of this. So as I was saying, that under usual circumstances, your kinetic friction does negative work. So when I give this a velocity, it stops. Why does it stop? Because the kinetic friction is retarding it. It is having displacement in the forward direction. Kinetic friction would be acting in the backward direction because it will try to oppose the motion. So yes, absolutely correct. Here the kinetic friction is doing negative work, but I can show you instances where this will do positive work. So suppose if I move my hand very, very fast. Okay, so I will try to do this. If I move my hand very, very fast. So the phone is right now here. Okay, now the phone is there, but you realize it slipped a bit. It slipped a bit with respect to my hand. I start this phone from here. All right, the phone is right now here, but if I move this hand very, very fast, so you realize the phone got displaced with respect to my hand and it did move forward. So if it did move forward, you will realize when the slipping was happening, the kinetic friction would be acting in the forward direction on the phone. Why? Because my hand was moving faster. So with respect to my hand, the phone was going backward. It was sliding backwards, right? If it was sliding backwards, now kinetic friction will oppose relative slipping, right? So it will oppose this motion. For that, the kinetic friction will act in the forward direction, and this phone actually, with respect to ground, got displaced in the forward direction. All right. Okay. No, not really. Not really. So again, Gopi Krishna, you also need to watch the video about pseudo forces. The phone does not slip because of pseudo force. The phone slips because of its inertia. Okay, and because there was not enough friction. There was not enough friction. If there was enough friction, the force would not slip. See, if I don't move it very fast, even if there is a pseudo force, it cannot cause the slipping. Anyhow, pseudo force is something very different. All right, so first you need to understand what pseudo force is. I know a lot of students have a tough time understanding what pseudo force is. So please do watch all the previous lectures of Newton's laws before in watching this video, because I am assuming that you have watched all my previous videos, you understand every concept that I have already taught, and then I'm taking this, assuming that everything that I've already taught is clear to you. Okay. So in case it is not, please go through those videos and make sure that you get your concepts right. All right. Next, if the work done on any object is zero, then either the force or the displacement is zero. Again, this is wrong. Why? We know there is another case that if the force vector and the displacement vector are perpendicular to each other, then also the work would be zero. All right. So that is another misconception. All right. So please remember, kinetic friction can also do positive work. Static friction can do all sorts of work, zero, negative, positive, and normal reaction, of course, does work all the time. Or not all the time, but yes, can do work whenever needed. All right, so if I hope everything about work is clear, the calculation part, the concept of how to calculate the work, and what forces can do work, what forces cannot do work. We will talk about this. We will come back to this later. All right, we will also talk about internal forces, external forces, whether internal forces can do work or not. I know there's a lot of confusion in students about that also. But first, let's talk about energy first. All right, let's introduce the concept of energy. After that, we will revisit this when we have discussed what internal and external forces are, and then we will talk about this again. All right. So what is energy? So first of all, just like I told you, that work was a mathematical thing that we realized has some significance, and that is why we defined a quantity. Now we realize this mathematical quantity is related to another mathematical quantity associated with bodies, which we started calling energy. All right. So honestly speaking, there is absolutely no way to define energy. It was initially defined as a mathematical thing which is associated with a lot of quantities, and then we realized this mathematical quantity has certain very unique properties, that this mathematical quantity always remains conserved. So we will talk about that also later. Alright, but right now you need to realize that once we discovered that there is a mathematical quantity f dot s, which we started calling work, it is related to another quantity which we called energy. And the very crude or very basic way of defining energy is that energy was defined as the ability to do work. Alright. So you realize the idea is that there are two concepts here. So first, Newton said that when force acts on a body, it produces acceleration. Alright. What acceleration does is acceleration changes velocity. Next, in the ideas of work, power, and energy, we see that if forces act on a body, they do work, and this work can change speeds. All right, not velocity. This work changes speeds. Right? If f dot s was zero, then you will realize there is no change in speed. Velocity may still be changing. The direction of velocity vector may still be changing, but the speed does not change. So these are the two approaches that we have. So if you do work on any body, then its speed changes. All right. So now, what exactly is it that you're doing to change the speed? All right. So, and how are you able to change the speed? So we say if you can do work, then you have something called energy. So these two terms are very deeply interlinked, work and energy. You can define one in terms of another. Sometimes, most commonly, we define energy as the ability to do work. Sometimes you define work as the amount of energy that you can transfer. So there is no distinction, there is no clear distinction between the definitions. As I said, we just looked at some mathematical quantities. All right, and that is how we started the study of work and energy. All right, so let us for now stick to this definition of energy, that energy is the ability to do work. So if suppose you can do some work on any body, then you say it has energy. For instance, suppose this pen is kept here. So right now, the earth is applying a force mg, but can it do any work? It can't. Why? Because it cannot cause any displacement. So there is a force, but it is unable to do work. All right. Now, if I raise this by, let's say, 1 meter, now if I ask you, can gravity do work on this pen? Now you will say yes. Now, if I let go, then the gravity can pull it down by a distance of 1 meter. So it can do a work of mg into h. That is what we call energy. Now we have given the body, gravity, a chance to do work on this. So we will say that we have provided this pen with some energy. All right. So that is what energy is. Energy is the ability to do work. So not to apply force. You may still be applying force, but if you can't do work, then you don't have energy. All right. So let's just stick to this definition right now. See, this is a very hard to explain concept. The concept of energy. There is no physical thing that you will see happening. All right. So it is slightly intuitive. You have to just develop the idea in your head that we are talking about something which is determining how much work we can do. All right. So let's just stick to this and let's try and understand this idea. Now I'm saying the entire approach of work energy rests on relations between work and energy. So as I said, so if forces are applied, they can do work, they can change speed, and if you can change the speed, you can change the energy. All right. And sometimes, if even if you don't change the speed, you can still change the energy. All right. So we will talk about that later. Now, energy, of course, because it is the ability to do work. Who do I admire the most? In what sense? In what sense? All right. In the field of physics, in general, otherwise, or what? Okay. Motivation. Okay. So personally, I had this friend of mine who I used to idolize. I mean, that guy was amazing. Is amazing rather. So he used to be my personal hero. All right. So I don't know. You meet people in life that you really admire. So that is one person who I really admire. You don't know him. He was a classmate of mine. He joined my school in class 11th. All right, and we became very good friends. And he was my best friend in my 11th and 12th years. Okay. So I will try and talk about that. So that guy used to be my inspiration. That guy was always so laser focused and amazing brain, amazing brain. I think he is one of the most intelligent people I've ever met. Yes, he did. He cleared JEE in one shot and he was All India rank 24. All India rank 24 in the first attempt. And at the same time, he took his boards where he scored 95%. At the same time, he went to International Chemistry Olympiad and he got silver medal. And he also went to International Astronomy Olympiad and he also got a silver medal there. Amazing guy, amazing guy. Such a calm guy, such a nice guy, thorough gentleman. And I have honestly never even seen him live once in his life. Okay. So yes, I mean that guy was amazing, amazing. I have never met a person like that ever in my life. Amazing guy. You'll have to ask him that. I never managed to do well in. He got selected for IPHO also, International Physics Olympiad also. He got selected, but he was already attending these, so he did not attend this because they already had a lot of contestants who could, go to IPHO. So the Indian government decided to send him here because here they hardly had any people. So he could only go for one. He got selected for both. He could only go for one. So Indian government sent him for this because there we had lesser people, and for IPHO a lot of guys were there who had good physics. Very few had good chemistry. So he went for International Chemistry Olympiad. All right, and he got a silver there. Yeah, full of achievements. Amazing guy. I, whenever I am in any kind of doubt, in life, even now, I call him and ask him for advice. Okay, amazing guy. Still a very good friend. Very nice person. So I don't know. I look up to him. Yeah, I really hope that I can be more like him. I myself was much more of a normal kid. I would get distracted very fast. I would though I was always bright and stuff, but I would have normal distractions like normal people. Yeah. So I we used to call him a robot, by the way, because I thought it was impossible to remain that focused all the time, that logical, that serious and professional. Currently, his profession. Okay, so currently he was also I think he had a GPA of 9.5 out of 10 in IIT Kanpur. He did his computer science engineering. Currently, he writes algorithms for trading stock markets. He is into algorithmic trading. All right. So, anyways, enough about that. So yes, great guy. One of guys I look up to. All right. So yes, another would be my father, of course, and I know he also worked really hard. All right, he had been very strict with us, but I know deep down he has always supported me, even if there were many a times where I didn't like his decisions and we disagreed. But yeah, I really appreciate his support and love also, of course. All right, so parents of course are always there for you. Shashwat, parents have this unconditional love and support. No matter what you do, no matter how much you screw up, no matter everything, they will always be there to support you. So of course, they are always one of the greatest supports and motivation for you. Always, that goes without saying. All right. I don't know. I think it might be just lagging for you, Mr. Anvesh, because stream seems to be fine now. Here. All right, so let's get back to our discussion. All right, let's talk about this. So as I said, if your energy is your ability to do work, so how do you measure energy? You will measure energy as the amount of work you can do, right? All right, if it is measured as the amount of work you can do, so obviously it should have the same units as work, and it would also be a scalar quantity. So energy is a scalar quantity and has the same SI unit as that of work, which is joules. All right. Now, in work energy power approaches, we see forces as means of transfer of energy through work. All right. So here comes the actual interpretation of work. So as I said, when you look at Newton's laws, you will realize that if you apply a force here, and if there are two bodies which are applying forces on each other. So suppose if one applies force like this, another would apply a force like this, right? So if one body applies a force on F vector, then another would apply a minus F vector force, right? So what these bodies do is that they change the momentum. All right. So in Newton's approaches, we see forces as a mechanism of changing momentum. So if the momentum is in this direction and your force is also in this direction, then the momentum increases. If the force is in the opposite direction, it decreases the momentum, and for any other direction, it changes the momentum in that direction. So in Newton's approaches, we realize that what forces do is that forces produce change in momentum. So when I said change in velocity, actually what we want to say is that F produces changes in momentum. All right. So in Newton's laws approaches, we look at force and the effect of force is that it is able to change. So F changes momentum. All right, changes momentum. That is NLM in your NLM approach. Now, when we are looking at it from a different angle, from the work energy angle, then what we see is that force does work, and what that work can do is work can change energy. So that is what work is. When you do work, work is changing energy of any body. Now you will know what positive work and negative work essentially mean. When you do positive work, so positive work increases energy, would increase energy, and negative work would decrease energy. Alright, so as I said, the definitions of work and energy are very, very interlinked. So you can always define one in terms of another. Alright. So now you can think of work as a means of transfer of energy. You apply force, you do work, and by forces you are transferring energy to or from the body. Alright. Negative work means you will take energy from it, and positive works mean you will give it energy. Alright. Next, in mechanics, so energy we later realize has many forms. Alright, so heat energy, there is light energy, there is all sorts of energy, electrostatic potential energy, and you have gravitational energy. So you may have a lot of forms of energy. Again, every energy, as I said, was nothing but a mathematical number that you realize that this number can be associated with a particular condition, and this number never changes. Alright. So there are different forms of energies, different reasons why the object can have the ability to do work, and all these can be described with numbers which we call energy. All right. So in mechanics, however, we deal mostly with two kinds of energies, either kinetic or potential. All right. So let's see what these are. So kinetic energy, let's have a look. So kinetic energy is defined as the energy possessed by a body by the virtue of its motion. Alright, this is the definition that you have read, and trust me, we don't have any better definition than this. So this is the definition that you will have to stick to. Now let's try and understand that. What does it actually say? So as I said, if suppose I said energy is the ability to do work. So if this pen is if this phone is kept here, and if I tell you that can it do any work on any object, let's say, which is kept here. So when this phone is stationary, can it do any work on this pen? It can't right now. But if I start moving this, if I give this a push, now you realize it went ahead, hit the pen, applied a force, and ended up displacing it. So if I give this a velocity, then it got the ability to do work on the pen. Alright. So if a body is moving, a moving body can hit a stationary body, apply a force and displace it. So moving body can do work on things and stationary bodies cannot. So that is why we realize that when a body is in motion, it acquires an ability to do work. This is what we are calling kinetic energy. Alright. Now, how do I measure this? How do I measure this kinetic energy? So for any object moving with a velocity v, it can be defined as the amount of work required to accelerate the object from rest to velocity v. What does that mean? Hi Phoenixian, how are you? So I said, fine, a moving object has the ability to hit a stationary object, displace it, apply a force on it, and do work. How much work? So now I can say, if I remember this example, when this phone hit the pen, it could displace it till the time it was moving, right? The moment it stopped moving, it could not displace this anymore. So any moving body can keep on pushing and displacing another body till the time this is moving. When it stops moving, it cannot do any other work. So if I want to calculate how much is the work that it can do before it stops moving, that I can calculate by two methods. Alright, one, I can directly see that suppose let's say that a moving body hit something and it applied a force normal reaction on it. Alright, so let's say its initial velocity was some u, alright, and it strikes something and it ends up applying a normal reaction on it, let's say n, and as a result it will also experience some N. So instead of N, let's just use F, because it's not necessary that it only applies normal reaction, it may have applied other kind of forces. So it applies some force on the body, and the body applies a reaction force on this, and as they are moving in contact, both of them are getting displaced by the equal amounts. Alright, so let's say after some time they both got displaced and the block reached here, and this guy got dragged with him with this. Alright, so this is an object, random object, which this block kept on dragging before it came to stop. Alright, or yeah, let's keep it that way. What is the meaning of that? Two significant ending 0 after decimal are significant. Alright. So, Phoenixian, you need to watch my video on significant figures. I have explained that in detail there. Don't worry, you watch those videos, you will understand that better. Alright, I've taken up a lot of examples there. So, okay. So you will realize if this guy is experiencing a force the entire time, it will have some acceleration. Alright, let's call that A vector, and this A vector is retarding this, so I can also calculate that V square minus U square equals to AS equation can be applied, right? And assuming the force is constant, I'm only assuming the simplest of the situation right now. I'm trying to figure out how much work can that body do on this other one. So if this was the force and this was the displacement S, you realize on this body the force would be opposite and the displacement would still be the same. Alright, so whatever positive work it can do on this, the same would be the amount of negative work that happened on the block. Alright, so one I have watched and come. Okay, so you need to watch the others also. So there are 3 videos. I think I've talked about that in the 3rd video. Alright, so watch all the videos. There are 3 videos about units and dimensions. Alright, hi Noman, how are you? I think I've watched, I've spoken about that in the 3rd video. So you realize what is happening here. When this guy hits this, applies a force, so it is doing positive work on it. As a result, this guy is doing negative work on it. So what is happening is, when this is doing negative work on it, it is reducing its kinetic energy, its energy. And when this is doing positive work on it, it is increasing its energy. So essentially, what these forces, action, reaction, they are doing is that they are transferring energy from this body to this body. That is why this is losing energy and this is gaining energy. Alright. So, and if I want to calculate how much is the work, then I can use this equation for this object. That how much was the negative work done on this body. Whatever is the negative work that this body had would be equal to the amount of work it transferred on the other body. Alright, so if I use this equation, then you realize that it would be V would be 0, so 0 minus U square would be equal to 2, and A would have a negative sign as well. Alright, minus AS if I wanted to calculate a dot. So now if I multiply both with M, both sides with M, what do I see? I see that minus Fs equals half mu square. Alright. So which means a body which was moving with an initial velocity u before coming to rest could do this much of positive work on another body, because this was the negative work that happened on this body, so it would have ended up doing the same amount of positive work on the other body. So that is why now I'm saying if a body is moving with u velocity, then I can say it has the ability to do half mu square amount of work. Alright. Okay, so Phoenixian, you will have to watch all the lectures. I hope you watch all the lectures. I have explained it there. And I have no other explanation other than what I gave there. So just watch it again and you should be fine. Trust me. I don't think you have watched the lectures carefully. Alright. Okay, by the way, I hope you realized how I got the expression half mv square. So now we know that any object when moving with a v can do half mv square of amount of work on any object before coming to rest itself. Alright. So please remember this. That is how we get the expression for half mv square. It's not out of thin air that we decided to start calling work Fs and we started calling kinetic energy as half mv square. It is in the definition. It is in the definition. Now you can also define the kinetic energy as the amount of work required to take a body from rest to the velocity v. So if this body is at rest and if I apply a force and I do certain amount of work and so that it starts moving with v, then where does this work go? I will say that this work got stored in the body by the virtue of its motion. When it started moving, now I gave it an ability to do work on others. And how much work will it be able to do on others? It will be the same amount of work that I did on it. Alright, so again, even by that logic, if you calculate, so if the body was initially at rest and finally it had velocity v and I applied a force F on it, right? This F produces an acceleration A, then I know that v square minus 0 square would be equal to 2 times A dot S. Alright, then again multiplying everything with M, I'm getting the same thing, that half mv square would be equal to F dot S. So I did a work of F dot S on it. So this is work done in getting the body from zero initial speed to a final speed of v. Alright, so this is what we are calling the kinetic energy now. Alright, so please remember this definition and you will see clearly that you are getting a term of half mv square. Alright, so this is what I wanted to show you. Alright, now remember, this is another way to define kinetic energy. So you realize, and that is why m becomes a measure of inertia. If you wanted to take two bodies, and from rest you wanted to take both of them to the same velocity, where will you be required to do more work? The body which has more mass. So again, work power energy approaches are providing you an alternate way of looking at everything. Alright, when you look at forces, you don't see their effects as changing momentum now. You see their effects as doing work and changing speeds or changing energy more fundamentally. Alright, next you also see that why is mass the measure of inertia? Why does mass oppose motion? You realize a heavier object would require more amount of work to be taken from 0 to v than a lighter object. It would be easier for you to make a lighter object go from u equals 0 to some velocity v. So you see, everything can be looked at alternatively with the approach of work and energy. Next, let's once we have defined kinetic energy, it was half mv square, but I also told you that this equation actually was this. Alright, this is the equation of kinematics that we use. So kinetic energy, being a scalar quantity depending on velocity, can also be defined like this: half m of v dot v. Alright, alright, can you guys see me now? So yes, there was a power cut at my place, because of which I suddenly lost my connection, and now the power is back. But the power cut, caused some problem. All right, so my usual net is not working, so I'm trying to use another network for this stream. All right, hopefully it'll be fine now. All right. So as I was saying, kinetic energy can also be described as half m v dot v, and of course from here you know it is a scalar quantity. All right. Next thing that you will know is that it can only be positive. So as I said, work can be positive, negative, or zero, everything, but your kinetic energy can only be positive. Why? Of course, you will realize that this is nothing but half m into mod of v square. Alright, now none of these terms can be negative. Alright, mod of v square always positive. Your mass is always positive. So obviously the kinetic energy is always positive, it can never be negative. Alright, so kinetic energy is always greater than equal to 0. That is what I can write here. Alright, as I said, I'm using an alternate network. So for this stream, because my regular network, I don't know, they just got shut because of the power cut, I guess. So this network is slightly fluctuating. It's not that steady. So let's hope for this to work, and otherwise I will check if I can get the other network to work. All right, let's see. Let me just check if my regular network is on now or not. All right. Otherwise, let me know if this stream is fine, or if it is causing too many problems. Then I will try going back to my original network. You can let me know. If there is too much lag in this stream, I will try and shut this stream and restart my stream with the original network that I have. Let me know quick. Or if this is alright, if you think I can continue with this. Alright, let me know. Yeah, this network is slightly unstable, so the net fluctuates a lot. Alright, so should I try and get connected with that? Alright, just give me 1 minute, then I will remove this network and I will try and get connected with my. So finally, yes, my net is back. So I think it's just that there was a short power cut. So because of that, my router got restarted. I think that is why it took a bit while connecting again. Alright, but it should be fine now. Okay, should be fine now. We should have a nice steady stream now. All right. So as I was saying that kinetic energy is always positive. It can never be negative. All right. Next, of course, your kinetic energy will depend on the reference frame. Please pay attention to this. This is again a very important fact. All right. Why? Because all your velocities will depend on your reference frames. All right. So if imagine this block was at rest with respect to the ground. So for an observer which is at ground, this appears to have no kinetic energy. But if you were an observer who is moving with v, you will see this block to be moving with a c backwards. So in the reference frame of this guy, who himself is moving with v, he will see that the block is moving in the other direction with v. So he will say Ke non-zero, and the first observer of the ground frame would have said Ke equals 0. Alright, so you do realize that kinetic energy will depend on the reference frame. Alright, for different observers, the kinetic energy would be different. Okay, so please remember that. So whenever you are asked to find the kinetic energy of any object, by default we always calculate it in ground frame unless otherwise specified. Otherwise, you should remember that it always depends on the frame of reference. All right. Next, of course, this is an instantaneous quantity. So we never talk about anything like an average kinetic energy. Usually not over a period of time. Kinetic energy is always instantaneous. It is the instantaneous velocity mod square. Alright, it is given by the mod square of instantaneous velocity only, usually. The expression this is only defined for a single point mass. So you will also realize this. So when I talk about the kinetic energy of any object, the expression half mv square that you use is only defined for a single point mass. Alright, for any body made up of many point masses, the kinetic energy is the sum of K of all the point masses. So in a special case, when this pen is moving like this, then all the point masses move with a same velocity. So let's say that is V. So in that particular case, I can call the kinetic energy of this entire pen as half mv square, right? However, suppose if it moved like this, all right, if it moves like this, so every point is moving with a different velocity, even if it is just rotating, right? Now also every point is moving with a different velocity. Now if I wanted to find the kinetic energy of the pen, what do? I would have calculated kinetic energy of this point mass, added this with kinetic energy of this point mass, this point mass, this point mass. I would have taken all the point masses, I would have added all their energies together, and that would have given me the kinetic energy of this entire pen. I cannot use the expression half mv square for this one, because there is no single v that you could have defined for this entire object. Why? Because all the points of this object are moving with different velocities. So please remember, half mv square you can only apply in two conditions. One, either all the masses are moving with the same velocity, or you have a point mass, alright, for a single mass. Alright, so please remember that half mv square is only defined for one point mass. You do not blindly apply that anywhere and everywhere. Alright, for big objects especially, you do not blindly apply half mv square unless all the points, let's say a block is moving with a velocity v such that you realize all the points will end up moving with v. Alright, all the points are getting displaced by the same amount in the same amount of time. So in this particular case, if the total mass was m, then I can use the expression half mv square for the kinetic energy of this object. Why? Because every point mass would be having a kinetic energy of half m I v square. All right. So when I add all these up, because v is same, so I will get my half and v square common, and summation mi would be nothing but the total mass of the object. All right. So remember this, half mv square you can apply for a big body as long as all its points are moving with the same velocity only. Now that we have talked about all those concepts, let's get started with some practice problems. Alright, so here is another problem. Let's see you guys try this. Alright, so this says a block of mass 5 kg is moving with a speed of 4 meter per second. You have to find the kinetic energy of the block in the ground frame and in the reference frame of an observer, which is moving with a speed of 2 meter per second in the opposite direction or that of the block. Alright, very easy problem, very straightforward problem, just to get you started, just to get you familiar with the formulae, so that when you're solving a couple of questions, you will hopefully remember the formulae also, and so that you remember the fact that kinetic energies will be different in different reference frames. Alright, so why don't you guys try this quickly? Just quickly try this. Alright. For TN 90, okay, let's see. So obviously this should be very easy. From ground reference frame, all you need to do is consider the velocity in the reference frame in which the kinetic energy has been asked. So block has a mass of 5 kg moving with a speed of 4 meter per second. So whenever I say it is moving with a speed of 4 meter per second, I hope you remember that all these velocities are by default always defined with respect to ground only. Alright. So for an observer at the ground, he will say m equals 5, v equals 4, so k would be half into 5 into 16. Alright, so that would be 40 joules. Alright, similarly for moving observer, you've also been told to calculate this kinetic energy. in the reference frame of an observer moving with a speed of 2 meter per second in the direction opposite to that of the block. So you have another observer who is himself moving with a speed of 2 meter per second here. So in the reference frame of this observer, he will see himself to be at rest and he will see the block to be moving here with 6 meter per second. So this is in the reference frame of this observer. So let's call this observer number 1, observer number 2. So this is observer 1 and this is observer 2. So observer 2 will see the block to be moving with 6 meter per second. Okay, good evening. So for this, obviously he will say M is 5, V is 6, so KE would be half into 5 into 36. So that would be 9 into 10, yes, so 90 joules. Alright, so these are the kinetic energies as seen by the ground observer and as seen by the moving observer. Alright. Now please remember, sir, is there any other session today on app? Yes, there is. So yesterday we had review of magnetism part 1. Today would be review of magnetism part 2. So today we'll be talking about motion of charges in magnetic fields. Alright. Alright, next we will come to something called work energy theorem. Now that we are clear about our definitions of work and energy, now this is where all the application of these concepts happen. Alright, so you will realize that the net force okay, I mean, any commitment about 12 board exams? So what kind of a commitment are you expecting? What kind of commitment? I don't understand. Alright, so the net work done on any object can be related to its kinetic energy as follows. That suppose you know that the net force would be equal to the acceleration. So you will realize that for any body that is moving, so I'm assuming for now that it is translating only. So what every work does is that suppose let's take a simple case of only a single force acting on a body. Suppose if only a single force is acting on a body and that too constant force. Okay, so for the sake of simplicity, let's just imagine that a constant force of F is acting on this body. This body had an initial velocity u and after some time it had a velocity of v. Now I can say that single constant force produces a single constant acceleration in the direction, maybe in the direction of velocity or the other. In any case, I can always use this. Alright, so equals to A dot S. So we have been talking about this equation all along. Alright, your video is lacking too much. Okay, yeah, that might be your internet. Okay, so about board dates. So how do I know? I don't decide board dates. You'll just have to keep following the news. So you realize we have talked about this over and over again. If we multiply this equation by m on both the sides, then what do you see? You will see that half mv square minus half mu square equals f dot s. Now I know the meaning of every term. What this is the kinetic energy final. So kinetic energy final minus what this is the kinetic energy initial. And what this is the work done. So this would be the relation between the work and the kinetic energies. So work done on a body is equal to the change in its kinetic energy, and that is support farmers. Okay. So yes. This is what we call the work energy theorem, and we find that this is the relationship between work and kinetic energies. Alright, so yes, we will do that, but please do not write things in the middle of the session. After your studies are over, then you can do whatever. You can't be losing time here from your studies also. Okay. So please, I got your message, Brar Games. I'm sure everybody got the message. Alright, so if you could stop writing that again and again, please do not spam. This is a live lecture. I'm trying to teach some students. Alright, we got your message. We will all support farmers, but once this class is over. Alright. Alright, your point is taken and we will support it. When will schools reopen? So okay. I don't know why you guys keep asking me that. I honestly have no idea. I will come to know with you guys only from news. Okay. Okay, so now no Pawan. Right now we won't talk about potential energy. I'm not talking about potential energy. All I'm saying is if I look at this expression, when any force acts on a body, then I will realize that it changes the kinetic energy. This is what my work energy theorem is saying. That any work act or done on a body changes its kinetic energy. So right now I am not talking about potential energy. We will talk about that later. But right now, I don't need to talk about the potential energy. Alright. See, the work energy theorem only says that the net work done by all the forces is equal to the kinetic energy. So we took the case of one force. We saw if one force is doing work, it is changing the kinetic energy. Even if you had multiple forces doing works, so the net work would be W1, W2, W3. So every force, when it is doing work, what it is trying to do is it is trying to change the kinetic energy. So when a lot of forces are doing work, then what you will say is that the net work due to all these forces would be equal to delta Ke. And this is what your work energy theorem is. You do not have anything about potential energy here. Please remember this. I am very afraid, sir, as I have not completed my maths. Okay. Two significant figures. Yes, Phoenixian. Alright, so you don't need the knowledge of potential energy for work energy theorem. Alright. Okay, so work energy theorem only says that the net work done by all the forces is always equal to. Okay, but you will never know the exact number, no, Phoenixian. Will you ever know the exact number? Will you ever know the exact number? You will be measuring every number by some instrument, and every instrument can only measure a number up to some extent. Okay. So if I told you to measure the length of this, can you tell me the exact length of this? It is not possible. Alright, Phoenixian. So even if you use a scale or a meter stick to measure, that meter stick has a limitation. Alright, it can only measure up to zero point 0.1 centimeter, right? So any measurements that you tell me will have a limitation in them. You will never know an exact measurement. Yes. Okay. So even when you're calculating speeds and velocities, you see you have to measure distances, you have to measure times. So any calculation has a limitation in it. All right. Okay. So now I told you that I can use this, that summation F would be equal to this, and I can use this. So this is what we call work energy theorem. Please remember that the net work, this is the work energy theorem. Nothing else. Do not get confused with anything else. The net work done by all the forces acting on our body is always equal to the change in its kinetic energy. That is the work energy theorem. You do not have the concept of potential energy here. You do not need the idea of potential energy here. Alright. Please, bra gamers, so please stop spamming and let's focus on the studies. Alright. Alright. So, and this is what your work energy theorem is. Alright, Pawan, remember that work energy theorem does not talk about potential energy. Alright. Now, let's take up an example of this. Let's take up an example of this. If I tell you that this is a pen which I raised from here to here. What is the work that I did? Alright. Now, you can use the work energy theorem here. Alright. You can say that if it had kinetic energy which is 0 here, when I raised this, I applied some upward force and I displaced it upward. Alright, it reaches here, let's say to a height of 2 meters. So I did some work, but what about its kinetic energy? Its kinetic energy is still 0. So how can that be? That would be because the net work done by all the forces would be zero. All right. Yes, yes. Because gravity is doing negative work. All right. So when you are saying, we will later talk about the work due to gravity as potential energy, but you don't need that concept in your work energy theorem. In your work energy theorem, you could have just said the other way around. They said this is the force applied by me, and this is the force of gravity. Alright, and if you displace this from here to here, so let's say by a distance of h. So you realize during this entire trip, the angle between mg and displacement is 180. Alright, what? Okay, so I guess I will simply ignore that. So from here to here, you see that work done by me plus work done by gravity should be equal to zero. Why? Because I don't see any change in the kinetic energy. The object was initially at rest, the object is finally at rest, so the change in kinetic energy is zero, right? And what is the work done by gravity? This I know. Work done by me and work done by gravity is minus mgh. Why minus mgh? Because the gravity force was acting downwards, the displacement was h upwards. So this is zero, and that is how I know work done by me would be plus mgh. Alright. So remember this. Alright. So that is what your work energy theorem is telling you. See, later using the concept of potential energy, you could have said that my work did not increase the kinetic energy, but it increases potential energy by mgh. So my work is mgh. So those are two different things, two different ways of talking about the same thing. But as far as work energy theorem is concerned, then you realize that is only talking about the work done by all the forces and the change in kinetic energy. All right, so please remember this. All right, let's practice a question to do that. An object is dropped from a height of 10 meters. Find out its velocity just before hitting the ground, and using work energy theorem. So we have solved this kind of question earlier with the help of this, right, this fact that the acceleration is g, and we use this kinematics equations to find the velocity when it is coming down a height of 10. All right, the answer is root 2 gh. Now you can also calculate the same thing using the approach of work energy. All right, so when this comes down here, what is the work done on it by gravity? So work done on it by gravity would be mg times the displacement d. Right, mg is acting downwards the entire time, the displacement is happening downwards, so the angle between mg and displacement is zero, so your work would be positive. And what is the initial k initial is zero. Let's imagine if final velocity is v, then final k would be half mv square. Now I can use work energy theorem to do this. All right. All right, so I can use work energy theorem to say work done by gravity would be k final minus k initial, which would be mgd equals half mv square minus 0. So from here also you will get v equals root 2 gd. So that is the answer that you will get. And here you know that the distance is 100, so your answer would be v equals 10 root 2 meter per second. All right. So just remember this. This is going to be your answer. All right. So this is the answer. Yes, we are sure. So why don't we try another question? All right. Why don't we try another question? So this says an object of mass 5 kg falls from rest through a vertical distance of 20 and hits the ground with a velocity of 15 meter per second. You have to find the work done by the drag forces on the object. All right. So you know in real life when you throw an object, so the air resistance, which provides a drag force which resists its motion, will also do some work. So here you have to calculate that. Sabresh, I already took one review of magnetism yesterday, and today I will be taking part 2 of magnetism review. Okay, on the app. So it was a special class. You can watch it. You can go there and watch the part 1 of the review, and you can attend the part 2 of the review today. Okay. Okay. Alright guys, so try this problem. Try this problem quickly. Alright guys. So okay, so Pawan says 125 over 2 joules. Okay, let's see. Let us see. So you know that you've been told an object of 5 kg falls from rest through a vertical distance of 20 meters and hits the ground with a velocity of 15 meters per second. And the value of g has to be taken as 10. Alright, so let's see what is happening. So the block is initially here and its initial velocity is 0 and the mass is 5 kg. It drops through a distance of 20 and reaches here. So drops through a distance of 20 meter and reaches here with a velocity v equals 15 meter per second. Now in this entire duration, there are two forces that are acting on this. Alright, one obviously is the force of gravity. So during the entire motion, one would be the force of gravity. Alright. Now another force would be drag force. Now drag forces have a very complicated expression. So drag forces usually depend on your velocity, or v square or v, and are opposite to the direction of velocity. So it will be very difficult to calculate the drag force value. Alright, so we won't even bother. I will just say, okay, there must be some drag force acting on it, and it will vary. It won't be a constant force, it will be a variable force, unlike mg. Alright. However, from my work energy theorem, now I can say that there are only two forces that are doing work, and work done by gravity plus work done by drag force. This should be equal to the change in kinetic energy. Right? This is what my work energy theorem tells me. So let's calculate the work done by gravity. Work done by gravity is very easy to see. For this entire duration, the force of gravity is downward mg and the displacement is downward 20. So work done by gravity would be 5 into 10, which is mg, into 20, the displacement, plus work done by drag forces should be equal to change in kinetic energy. Final kinetic energy is half into 5 into 15 square minus initial kinetic energy, which would be 0. Alright, so I can simply calculate my answer using this. So this will become 1000. So work done by drag forces would be, so, and this would be 225 into 5 by 2. Okay, so that will be 15 square would be 225, right? So let's just quickly calculate this. Yeah, 1125 by 2 minus, that would be 1000. So what you realize is that the work done by drag forces would be negative, by the way. Alright, it would be minus 875 by 2. Okay, I don't know what. Yes, that is the correct answer, minus 437.5. So you guys are still making a lot of mistakes. So you need more practice, guys. Need more practice. That is the correct answer, minus 437.5 joules. Alright. So okay, so I think now you should have an idea of how you will solve your problems using work energy theorem. So you can find works if their works are unknown. If all the works and forces are, if all the forces are known, then you can find the works and then you can find the change in kinetic energy. Alright, these are the kind of questions that you will have with respect to the work energy theorem. Alright, so get some practice, because turns out you guys need this practice. So today is Friday and I will see you next on Monday. You have like 3-4 days to get some practice. Alright, so make sure you do that. Make sure you get your answers right in one go. Alright, because you don't want to be making mistakes in your JEE exam like this. Alright, so get some good practice, get good with calculations of work energy and you applying the work energy theorem. On Monday, we will take this discussion forward and we will talk about potential energy also. Alright. Okay, so maths and chemistry also. So what do you want me to tell you about maths and chemistry? See, the pattern has changed so much since I took the JEE. I keep telling you, when I took JEE, it was subjective. Alright, it used to be subjective. So very, very different kind of paper. So the kind of things that I studied won't really help you much here. So I don't know what advice can I give. What I can tell you was that I would divide my time. I would study 8 hours a day, 2 hours physics every day, 2 hours chemistry every day, and 4 hour maths every day, because I used to be weak at maths. So I would practice maths for 4 hours a day, and maths requires a lot of practice. All right. So in physics, chemistry, what you can do is maybe in half an hour go over all your lecture notes. For which, obviously, when you are attending live lectures, you should be preparing your own notes. Half an hour would be more than enough to revise your lecture notes, and then every day revise your lecture notes and practice for 1.5 hours. So 2 hours should be enough daily for chemistry and physics if you are doing that. Alright, and 4 hours of maths practice. So that is what I'm saying. Alright, Rishabh, I hope you got the idea. So one, you should have your notes. Now, what you can do is you can daily divide some time. Now, since you guys have schools, so you probably won't be able to manage 8 hours, but maybe manage 6 to 7 hours at least. All right. So manage at least 7 hours of self-study. No, I'm talking about 7 hours of self-study. Or if you can't manage that, at least try and manage 5 hours of self-study. So what you can do is you can study physics and maths one day, and then let's say physics and chemistry one day, and maths and chemistry one day, and you can juggle through with these subjects. All right. So yes, 2 hours of self study per day would be required at least. If you can manage more, then well and good. Then see, when I was preparing for my JEE exam, I told you guys that I took a drop of 1 year. All right, because 11, 12 I was doing self study, so I did not do that well. So when I was preparing for JEE, I took a drop. I did not have to go to school, so I could manage 8 hours of self-study daily. Alright, that was besides my classes. Alright, so then you can manage it easily. So I would give 2 hours to physics. That was my routine. Again, so you may have your own routine. I would give 2 hours to chemistry, and I would give 4 hours to maths every day. Again, this was my routine because I used to be really weak at maths. So I wanted to give extra time to maths daily. Alright, and in this also half an hour for revision, 30-minute revision, and 1.5 hour practice. So that is what I used to do, and I don't know, you can try that, and you can divide the timings in your different subjects according to wherever you find that you need to give more time. Alright. So that is the advice from my side. Alright, now before I leave you, let me remind you that you should be getting your Unacademy subscriptions if you haven't gotten them already. And this is how you do it. You go to the plus section, you select your goal as IIT JEE, and you click on that get subscription button. Alright, and when you're getting those subscriptions, you can use this code RD Live from my side. Alright, so yes, Brar gamers thought that the fees is too high. Okay, unfortunately I don't decide that fees, but trust me, this fees is very less compared to what any good coaching institute would be charging you offline. As I keep saying, I have been a part of offline coaching institutes. They charge you fees which is 8 to 10 times this. Alright, so I'm sure Unacademy has a reason for charging the fees that they are charging, because I'm sure they have to maintain a lot of things themselves also. Where I can help you is, I can tell you can use this code and get 10% off. That is from my side. Alright, so that is what I can help you with. Otherwise, I don't decide the fees. Alright, so there is nothing much I can do about it. But trust me, even at these prices, this fees is very, very reasonable. Alright, now if you like today's video, then press the like button and share it with others. As I keep saying, that if you find this subscription fee also to be very high, if you can't afford this, then also don't worry. We are taking regular lectures on this JEE English channel. We are providing free quality education. We are providing free support for your JEE preparation. So if you can't afford this fees also, then also don't worry, Brar Games. You can just follow us on YouTube, and we will try to help you with your JEE prep as much as possible. And for to make sure that more and more students benefit out of that, make sure that you are sharing it with all your friends. All right. Don't forget to press the bell icon, and the PDF of all the notes used in today's lecture would be available for download very, very soon. All right. Those of you following us on the JEE English channel should be connecting with us on the Telegram app using that link, so that you're not missing out on any lectures and sessions which are planned on this channel. And before I go you, if you're planning to get your Unacademy subscription, use this code RDLive, get a 10% off, and I will see you there then. Alright, so I will see you next on Monday. Till then, you revise all your concepts. Make sure you have practiced. If you haven't watched my previous videos of Newton's laws, make sure you have watched them also. And I hope to see you prepared on Monday. Alright, so till then, you guys keep practicing, keep studying, and